and it has no holes because there are no common factors in the numerator denominator, right? So it has no holes. X-intercept, you look at the numerator and you check, you want to find out if there's any x value that makes the numerator 0. And because this is an x squared plus 1, nothing, no real number makes it 0, so there is no x-intercept. For y-intercept, well, it doesn't have one either because it says x cannot be 0. And again, if you try covering up the x's, you get 1 over 0, so it's undefined, so it has no y-intercept. So as for vertical asymptote, it does have one, it's x equals 0. And for the slant, again, because this is a top heavy, it's going to have a slant asymptote that we get through division. Now I can use synthetic division here because my a value is 0. So when you do synthetic division, it's going to be 0 because it's x. I'm dividing by x minus a, which is, right here, it's just x, so that means that a is 0 because there's nothing here. So the 2, I need a placeholder for x, and then I have the 1. Bring down the 2, 2 times 0 is 0, you add that, and 0, and you add 1. So this ends up being the remainder, and we don't care about the remainder in this case. So the horizontal, or sorry, not horizontal, the slant asymptote is y equals 2x. Okay, that's the slant asymptote. So let's go ahead and graph it. Alright, so first we'll start off by graphing the vertical asymptote, x equals 0, so it's right over the y-axis. The slant asymptote is y equals 2x, so it's going to be, the slope is positive 2, so up 2 over 1, so it's going to go here, it starts on 0, and here I'm just going to draw the dots to guide me, and then I can do down 2, left 1, down 2, left 1, down 2, left 1, okay? So, like that. Okay? And that it has no intercepts, it has no holes, so all we have left, all we can do here is, well, we can reason our way through if, watch, I know that it's going to have two curves, one on the left side of the vertical asymptote and one on the right side, right? Since I know that it has no x-intercepts at all, I know that on the right side, there's no way it can go here. No way, because then it has to cross the x-axis. So this tells me that my curve has to be up here. Okay? On the left side, similarly, I know it can't go here, because then it would have to cross the x-axis. So then the curve has to go in here. Okay? So just to get an idea of how, how high the curve is going to go, I'll plug in a 1, just to figure it out. So f of 1, we'll change the color. F of 1 would be 2 times 1 squared plus 1 over 1. So 1 squared is 1, so 2 plus 1 is 3, 3 over 1 is 3. So 1, 3, right here. Okay, so just going to connect here, connect here. Now I don't know, like, if it actually curves up right here. It could actually go lower and then curve up. That you can't tell by, just doing that one point. You need a graphing calculator to give you a more accurate picture, like we did in class today. Okay, same thing, we're going to go and find f of negative 1. So then that's going to be 2 times negative 1 squared, so that's 2 plus 1 over negative 1, so that's going to give us negative 3. So negative 1, negative 3. Okay, so same thing, I think it's just going to curve like this and go like that. That's good enough for graphing by hand. Again, check Desmos and you'll get a more accurate picture. So for 52, we're going to factor the denominator, so that gives you x plus 1 times x minus 1. Okay, so the domain is x such that x cannot equal plus or minus 1. So there are no holes here because there's no common factor in the numerator and denominator. The x-intercept, there is 1, 0, 0, because that's what makes the numerator 0, right? X cubed is by itself, so what makes that 0 is 0. Well, if the x-intercept is 0, 0, the y-intercept has to be 0, 0. Vertical asymptotes, x equals 1 and x equals negative 1, because, again, that's what makes the denominator 0. This is a top-heavy problem, and I can't use synthetic division, unfortunately. So I'm going to have to do long division. So x squared minus 1, x cubed. So x squared goes into x cubed x. We multiply negative x. And so that when we subtract, you get x. That's a remainder, but we don't care about it. So then this is your y equals x is your slant asymptote, okay? Alright, so first we draw the asymptote, so we have x equals 1, and x equals negative 1. Then we have the slant asymptote y equals x, and down this way. Okay, remember it has to be dotted, so let me add a couple more, erase parts of it. Okay, so x-intercept and y-intercept is 0, 0, so here, okay, this function is actually odd because when you test for symmetry, and I know we haven't done it consistently for every one, but just because where I see the asymptotes and how the slant asymptote goes, replace all the x's with negative x and you'll get the opposite of the function. Okay, you'll get the opposite. So this is an odd function. Okay, so whatever, and we'll see what it looks like in a minute. I'm going to calculate 1/2, because see right here, I want to know what happens here. Does it go below the line or does it go above the line? Okay, that's what I want to know. From the 0, 0, does it go down or does it go up? So I don't even really care about the value, I just want to know the sign. So f of 1/2, and let's see, I need a spot. So f of 1/2, so 1/2 cubed is a positive number, correct? And 1/2 squared is 1/4, minus a 1 is a negative number. So a positive over a negative is going to give you a negative. So that means that on the right side of 0, 0, it's going to go down. Okay? Since this is an odd function, if the right side goes down, then the left side has to go up. Okay? And if you don't really trust yourself with that, just try negative 1/2. Well, negative 1/2 cubed is negative. Negative 1/2 squared is positive. Positive 1/4 minus 1 is negative. So a negative over negative is a positive. So the left side, this piece right here, is going to go up. Okay? Now, I know that on the right side, because this is broken up into 3 sections, I've got a curve here, a curve that I already drew here, and then a third curve over here. Well, this side I know has to go up here. It has to, because it can't cross the x-axis anymore. It only has one x-intercept right here. So there's no way the curve could be down on this side. It has to be up here. So I'm going to try f of 2. So f of 2, I get 2 cubed over 2 squared minus 1, so that gives me 8. 4 minus 1 is 3, so that's 2 2/3. So 2 gives me 2 2/3. So that's about here. Okay, and that's all we need to graph our curve. Something like that. Okay, so because 2 comma 2 2/3 is a point on the graph, and I know this is an odd function, and I'll show you, I'll go back real quick and go over why it's an odd function. So then I know that negative 2 2/3 is also on the graph. So negative 2 and 2/3 is also on the graph. So connect and connect. So there's the picture right there. So real quick, reviewing how to find even or odd. So I'm going to replace all the x's with negative x cubed over negative x squared minus 1. So negative x cubed is negative x. I'll put it right here. Negative x cubed is negative x cubed. Negative x squared is positive x squared. So this is the opposite of this one up here. Because when I multiply the top by negative 1, I get this. So this one and this one are opposites of each other. That's why I knew that this function was odd, and so all I had to put in was the positive 1/2 and the positive 2, and that's all you needed to graph to get a better picture. Okay. Alright, so number 55, domain is all reals because nothing makes the denominator 0.